Hello everybody and welcome back to episode 16 of our video series in which we program an entire video game from scratch in the C programming language. So last time we were right here, jump right into it. So what we did last time is we wrote a function that would load 32-bit bitmaps, and I was already way over time, so we had to stop right before we were able to draw the bitmap that we just loaded onto the screen. So that's where we're going to start today. So what I'm going to do is, and notice, remember that the bitmap that we wanted to load, which is right here, is basically of just our character in a standing, facing us sort of pose, just standing there. We already loaded that into memory. We did that last time. So I think what I'm going to do this time is I'm going to make a new function, and I'm going to call it I'm going to call it Blit32BppBitmap. Onto screen. Or onto buffer. Maybe something like that. This function is going to take in as a parameter a pointer to a game bitmap. We need a X position and a Y position. And so I'm thinking the reason why I'm making these unsigned integers is because since our origin is 0, 0 at the top left corner of the screen, there's essentially no possible way for there doesn't exist any negative coordinates in our world. And also it only needs to be 16-bit integers because we have a very small resolution of just something like 384 by 240 pixels. So I think an unsigned 16-bit integer is plenty. You probably wouldn't notice any difference if you use 32-bit integers or just signed integers. Doesn't really matter. I'm just being extra. Alright, so now I'm going to go down here into my C file and I'm going to create this function. Again, this function, it returns void because I don't care about the return value. It's essentially designed to never fail. I mean, if we fail to blit something onto the buffer, then the game might as well crash. There's no reason for this ever to fail, ever. So let's see. First thing we need to do here is, so we basically have we already know how to basically draw a little square onto the screen, don't we? In our render frame graphics function, that's essentially exactly what we're doing right there. And we're making a starting screen pixel. So this right here is going to we're going to reuse this in our function. The only difference is that instead of instead of setting down a blue pixel, or sorry, a white pixel, instead we're going to basically pick a pixel up off of the bitmap, and then we're going to use that color, whatever color it is, and place it down in the appropriate place on the screen. So we're transferring the bitmap onto the drawing surface. Alright, so let's just start with a starting screen pixel. Let's see here. I already know what it's going to be. It's going to be game res width times height. Let's say width times height minus width. And then, let's see. Times y plus x. Memory offset. We're going to create a memory offset here. And we'll create a bitmap offset here. I feel like I probably should have like a starting bitmap pixel as well, which would be something like bitmap info dot bmi header dot width times height. It's basically a scaled down version of the starting screen pixel. Since you remember our back buffer is essentially just a giant game bitmap. It's essentially just a game bitmap that fills the entire screen. We're just blitting a smaller version of that game. We're blitting a smaller game bitmap onto a larger game bitmap. Okay, so then we do equals width. All right, let's move on. We may have to revisit that. I'm not sure if that's right or not. Okay, so essentially here comes our nested for loops. We're going to do and we may enhance this function later to maybe we only want to draw subsections of a certain bitmap or something, like maybe we only want to draw half of a sprite for some reason. We could enhance the function later to do that. We'll have to manipulate all this arithmetic again, but for now, let's just write it such that it's just going to blit the entire bitmap from 0 to the entire width and height of the whole bitmap. I'm also not going to worry about SIMD, where remember when we did our SIMD version, we incremented by 4 each time. We're not going to do that this time because well, there's 2 reasons we're not going to do it. Is because number one, you don't really get much benefit out of SIMD unless you have large repetitive workloads, and a 16 by 16 pixel bitmap or sprite is not really big enough to justify going down that route. And the second reason is it becomes much harder. It becomes much harder on us because we actually need to know the value of each individual pixel one at a time for doing this operation. Because, like, for example, I guess I'll draw it for you. Let me see here. I'll show you what I mean. Say we have our whole screen there, and let's say I'm drawing this bitmap right here, and let's see, it's say it's like a person, and he's got a head, and he's got a torso, and he has legs, and he's got an arm like that, and that. That's pretty good. Okay, so let's say we're drawing this one, and the first iteration of the loop, if we were to draw 4 pixels, this one would work out fine because these are all the same, right? Like, this is our blue background color. I wish I had colors in this program here, but apparently not. But like, if I'm drawing that pixel and that pixel and that pixel and that pixel all at the same time, that works fine because all of these are like background pixels, and in our instance they would just be the blue pixels that you see behind the sprite, right? So that will work fine. But on the next iteration, maybe not so much, because this color and this color and that color and that color may actually be different. So I have to go and inspect each one of those colors and like alpha blend it and all that kind of stuff. It's a pain. So yeah. Anyway. Okay, so for each one of these pixels, we're going to calculate memory offset and a bitmap offset. So the memory offset is going to be game res width times y pixel. String screen, and then the bitmap offset is going to be hang on a second. Starting screen pixel plus x minus width times y. Okay, now back to bitmap offset. It's going to be starting bitmap pixel plus x pixel minus the bitmap width times y. And so now I'm essentially going to have to do two memory operations. One, I have to take the pixel, I have to mem copy or lift the pixel out of our game bitmap, and then I have to do another mem copy to set that pixel down on top of our or into our back buffer, right? Okay, so mem copy. Our destination will be bitmap pixel, which is a pixel 32. That's 32 bits, 4 bytes. We're going to cast this to a pointer game bitmap memory. Destination wait. Destination size of pixel 32. Okay, this is source and source size. Let's see if that compiles. And then for our second copy, we're going to basically copy the pixel into our game bitmap or our back buffer, right? So let's see here. Memory. Source will be that pixel, and of course the size of it. Now, in between these two copy operations, this is where we will do all of our additional processing. Like we may want to skip this if the alpha of our bitmap pixel is not 255 or not 0 or whatever. Basically, if it's transparent in that one area, then don't draw it. Let's run it first. Let's see what happens. Think it's going to crash? It might. Huh. Okay, that's because we never called our 32-bit bitmap-to-buffer function, did we? All right, let's go to render frame graphics. And let's go to, I think we can comment all of this out. Blit32 bitmap-to-buffer, and we are going to give it our, what did we call it? Wait. gplayer, and our player has sprites. Okay. Suit 0, which is more essentially the index is 0, 0, right? Facing down 0. Since that's the only bitmap that we've loaded so far, but pretty soon we're going to load all 12 of those sprites so that he can turn and do different directions. Alright, so now we need an X and a Y, so that's going to be gplayer.screenPoseX and gplayer.screenPoseY. Alright, moment of truth. It's broken. It's broken, and there's a little white pixel in the bottom left corner. That is strange. So I obviously did something wrong. Let's go see what I did wrong. Okay. Starting width times height minus width minus width times y plus x. that all seems to work fine. I mean, that all seems to make sense. Now we have starting bitmap pixel. We have width times height again. Minus width. Okay, I guess we'll just go debug this and see what it looks like. Set a breakpoint and go. Okay, so our starting screen pixel is 82,201. Our starting bitmap pixel is 224. This doesn't sound right to me. It would help if we added our offsets here, wouldn't it? It sure would. And there we go. Okay, so it looks like, okay, this looks almost successful. It's not perfect, but it's very close. So if I look here, it's not see that mine has like some weird, and it's ironic because I like 1 or 2 episodes ago I made it so that you can't see the mouse cursor whenever it's hovering over our game, but now I kind of wish that I could hover the mouse over our game because I want to show you something, but that's fine. But anyway, notice the bottom layer, something is not quite right about that. It's drawing like a black line. And I feel like it's cutting off. Okay, so we're starting, I think we're starting our like our Y pixel is 1 off, because that feels like we're starting 1 row too low. I feel like that's our problem. See, because it cut off the very top of his head and it added a black bar underneath his feet. So we're doing something wrong there. What are we doing wrong? Okay, Y pixel starts at 0. Those both start at 0. 16. This must be the problem right here. Everything else looks correct. Memory offset equals starting screen pixel plus X pixel minus width times Y. Bitmap offset equals pixel starting bitmap pixel plus X minus game bitmap width times Y. I'm just double checking to make sure that I can't accidentally walk beyond the bounds of the screen and crash the game. But I cannot, so that's good. Alright, so the starting bitmap pixel has still got to be our problem. There it is. Perfect. I just had one too many width, a little too much width in there. So I was starting at the wrong offset. But now it's perfect. So we just blitted a 32-bit bitmap from memory onto the screen. Looks great. All we need to do now is load in the rest of our, oh, no, actually, before we move on, there's something else I want to do. If bitmap pixel dot alpha equals 0, or is it 255? 255. There. How awesome is that? So now essentially we have transparency. You can see the background around the little dude instead of it being a white square. We're simply just, if the alpha is full on, then we draw the pixel. If the alpha is not full on, then we do not draw the pixel. So, as I said before, like, this is not the way that most people do it. Most people would be using like maybe a 24 or 16-bit bitmap, or if you're running if you're using like an old school NES or something, you may have like an 8-bit bitmap, for example, and the difference is like you don't have a transparency layer, so you end up using some hideous color like this to represent your transparency, and then you would do something just like what we did over here, where it's just like, if it's this color, if the pixel is this hideous pink color, then don't draw it, and it achieves the exact same result of having that sort of transparency there. So but we may actually end up doing more with the alpha channel later. Just for right now, this is all we're doing right now. It's just kind of a binary on or off, like, is it transparent or is it not transparent? But later on we might have situations where we want to do, like, to blend one bitmap over the top of another, and just so that like the result will be the blend of the two. You know, just like you put if you put a blue piece of film and a yellow piece of film on top of each other, the result is like green, right? Blue and yellow make green. Well, that's the sort of blending I'm talking about. Anyway, so yeah, when we're ready to do it, we'll do it in this function here. But so this is actually really cool. It's kind of a landmark moment, because now that we have this function done, um, we're also very close to having text done as well, because we're going to draw text using this exact same function. So that's our font, our letters are going to be little bitmaps as well, and it's going to work exactly the same way. So okay, let's go back and load the rest of these sprites now that we have them. And where are we loading them? Initialize hero, right? Okay. Actually, I want to fix this issue first. I remember last episode, I was having an issue where I couldn't get the path to work out properly, and it couldn't find the bitmap, but I don't want to use fully qualified path names either. In fact, I can't use fully qualified path names, because as soon as I take this to someone else's computer, this path is no longer valid. This path is only valid on my computer, so it's just not going to happen. It's not going to work. So the problem here is that let's run this. Now let's launch Process Explorer. Now the current directory is C users Rhino source repos game B. That is the current directory. So let me close this, let me exit this, and let me go find it on the hard drive. I closed Visual Studio completely. Debug, maybe, there we go. Now if I go back over here to now notice that the current directory is C users Rhino source repos game B x64 debug. So the point that I'm trying to make is that the current directory of my game is different depending on whether I'm launching it just normally through, explorer.exe, just double clicking on the executable, or if I'm running it under the debugger, under Visual Studio. It actually makes the current working path different. So what I could do, I kind of would just like everything, all of my assets to be in the correct place, regardless of okay, glad I checked. When I opened Process Explorer, it broke the audio in OBS again. So luckily I caught it and didn't waste a lot of my time. But the point that I was trying to make is that when I run my game just like this under normal circumstances, just double clicking the executable, the current working directory of the game is different. It's in here. It's this whole path right here. But if I launch the game under a debugger under Visual Studio, then the current directory of this game is different. than it was before. So no single relative path is going to suit both situations. So to fix this, I think what I might do is I might copy, like what if I did this? What if I went to properties? Now I think that there is a build event, post build event, command line. We are going to write a batch file that is going to basically copy our assets folder into every place where our game is going to run from. So whether it be in the debugger or outside the debugger, all of our assets are going to be there. I think eventually what I'll do is, instead of having an assets folder with all of our bitmaps in it, I'm probably going to make an archive, like a .zip or .bin or something, that basically keeps all of our assets will be inside of there, and then the game will extract them, and then we, instead of having to load them off of the file system. But we're not there yet. That comes at some later time. So, all right, let's get back to this. What are we going to do? I am going to write a batch file, and I'm going to call it copy assets.bat. Okay, source to destination. Now, if I go to project properties, post build event, I think I can run it. Let's just copy the fully qualified path name out of there. Okay. So now if I go and build it again, let's see what happens. Game B, x64, debug. No, it did nothing. Okay, it works if I... Guys, I had it on Win32. Why? Why was it on Win32? All platforms. Okay. If I delete that, build it again. Didn't work. Ah, here we go. The command. The command exited with code 123. Okay, now it started working and I changed nothing. So, cool. So essentially, the idea was that every time I build the game now, it's going to copy my assets directory over into this directory here. That way, I can use relative paths and the wherever I run the game from. Essentially, I'll have a copy of the assets folder so that I won't have any problem locating my bitmaps. So now that that is taken care of, we need to load the rest of these bitmaps, which means we need to find the rest of our bitmaps, which I have conveniently located. Alright, so I have all of the bitmaps here already taken care of, and again, if you open them, you'll see that they're the same. They're cut out, and they're all 16 by 16 pixels. There we go. I probably need to rename them though. Suit 0. So that we don't get it confused, because it is Suit 0 in our code, so I should probably make it Suit 0 in our file names as well. So these have names like standing, walk 1 and walk 2, but over here in my code I just did facing down 0, 1, and 2. I think I'll leave it as it is for now though. Yeah, so essentially I just want to load all these. One, walk 2. I just wanted to add this first line into our post-build script, just so that in case I change or update any of the files in our assets folder, those new changes will get reflected into the wherever I decide to copy the assets folder. So, all right, let's run this and see what happens. Obviously, these need to change. This needs to be facing down 1 and facing down 2. And let's see what happens. There we go. Now, we basically need to animation. It's a pretty big topic. All right, so I think we'll probably leave off there for today. Obviously, the main thing we got accomplished today was that we finally are drawing bitmaps. We're loading bitmaps from the file system, and now we're painting them onto the screen, including with transparency. And the next thing we need to do is we need to animate, so that while we're walking, we can utilize all those different walking animation frames. That'll probably take up the rest of the next episode. So that will do it for today. And so, as always, thank you for watching. If you have any comments or questions, please leave them on the video, and I will address any comments in an upcoming episode. In the meantime, don't forget that we have a GitHub repository that stays updated along with these episodes, so you can follow along using that GitHub repository. And yeah, until then, I'll see you next time.